So we're going to continue logging data changes in Entity Framework. So we need to consider database size and table size. If we're logging all the properties, the database size is going to get big very quickly. So we're going to go ahead and look at some functionality into ignoring certain properties that we don't need. We also want to be able to log data changes for references. So when an entity is related to another entity, we want to log the actual data changes for that particular reference. Then we're going to have a look at SQL Server's JSON functionality and build up a query based on a JSON string. So we can basically use the JSON keys to build up a query as columns in SQL Server. Finally, we're going to have a look at test-driven development. So let's head over to our example.
So one of the problems at the moment is that we're logging all data changes regardless. And there's some properties that we don't really wish to log data changes to. Some of these include the ID, because we're already including that as a reference ID in a separate column. And also we've got the created. We don't really want to be logging that either, because we've already got a timestamp for when we log our data changes. So I've gone ahead and I've created this change ignore attribute. Now what I've done in the base class is I've actually applied it to the ID created, last updated and deleted. What that basically will do is that it will ignore any changes from those properties. But that alone won't make it work. We've got to do a bit of extra work. So what I'm going to do now is I'm going to go into the base change service and go down to Populate change properties. So I've had to make a couple of changes here. So we're going to talk about references in a bit. But here, basically, what we're saying is we're looping through each property, and if it has the change ignore attribute, then we continue to the next property. So we're not going to go down here and do all the changes that we need. So now we've gone ahead and created this change reference attribute. Now what this is going to do is it's going to log data changes for any entities that have a relationship. So to show this, I've created this new engine entity. And basically a video game will have an engine. So we've had to make a couple of changes in video. We've created this engine ID and specified an engine reference. You may have noticed as well that we've got this change reference attribute up here as well. We've also had to add something into the onModel creating, and this is basically specifying that a video game has one engine. And vice versa, an engine has many video games. So now we need to populate this, and what I've done is I've created a new function, a new method. So this is getChangeData reference, and what this does is that in the entity entry that we're passing in, you can basically get a list of references that are associated with that entity. So what this does is it loops through each entity reference and loads it. What the load function does is it checks to see if the reference has actually been loaded in before. If it has, it doesn't do it again, but if it does, it will load it in. Once we've done that, well, it makes sure that it's not null. And then after that, it will go through and call our populate change properties. Now, a reference could have references as well. So what we're going to do is we're going to recall the getChangeData reference. So it's almost sort of getting itself into a loop. And that can cause some sort of challenges. We've got the issue where basically it could go down too many depths and get into a complete loop. We've also got the problem where the actual function will get called too many times. And again, it will get itself into a silly loop. So what I've made sure that's going to happen is that it only goes down 2 depths. It can't go down any deeper than that. We're also checking and making sure that this function isn't called any more than 100 times. And if it does, it throws an exception. Now we need to implement that into our create async and update async methods. So in the create async, we just basically call it after the getChangeData. Pretty straightforward. Slightly more complicated with the update though. So we have to create it before we're setting the values. We basically have to call it twice when updating. So this is one of the issues with references. when we pass in our entity up here, we have to make sure that it's not being tracked in DB context. If it is, if we were to update, say, the engine ID in video game, it would have already updated the reference in here. So we have to go ahead and call it before we even set the changes in update entity. Once we've done that, we've called it there, we've stored the information, we go ahead, set our values, make sure it's modified, and then we call it again after our get change data reference. So now we look at the display name attribute. Now, at the moment, we are storing information regarding the property name. The problem with property names, though, is that you can't have spaces or special characters. So we could go ahead and create a new attribute to store that. But we don't need to because we've got the display name attribute, and we're going to be using that to store the display name. So in this example, I've got the video game entity, and for the release date, I'm displaying the name as release space date. So we need to make a change to our Populate change properties to store this information. So once again, when it's looping through all the properties, it checks to see if the property's got a display name attribute. If it does, we'll store it in a variable called display name, as you can see here. So now we come to the change data that we're logging, and one of the issues we've got at the moment is the fact that when we log data changes, we're logging it in a JSON format. So how do we go about using this to query it in SQL Server? How do we filter it, and how do we order it? Well, what we can do is we can use some of SQL Server's JSON tools. We've got this open JSON and this JSON value. So with the open JSON, what it's doing is it's looking in the change data and getting the change properties, and then it's basically forming a table with all the keys that are in that JSON value. So if we were to run it here, as you can see below, it's basically put all our data from our JSON into columns. What we can do now is we can go ahead and sort of order stuff. So if we want to order it by the current value, we can go ahead and do that. So if we execute that, as you can see, now it's being ordered by the current values. So how do we set that up in Entity Framework? Well, what I've done is I've created this change view entity here, and this is basically copying the same columns in the query that I've just shown you. So you can see here, you've got change ID, reference ID, the create, updated, deleted, property name, etc. And as you can see, it pretty much mimics what's going on there. So how do we make this work in Entity Framework? Well, we need to declare this onModel creating, and we need to tell Entity Framework whether the entity has a key or doesn't have a key. So if we go back in here, you can see it hasn't got a unique ID. We're using the same change ID for all properties that are being stored or being logged as data changes. So we haven't got a key. So we basically need to tell Entity Framework that it has no key. We then have to make a small change in the change DB context, very similar to what we were doing above for the base change. For the change view, we need to make it a generic type with the current entity. Then we can go ahead and invoke our onModel creating method. Now, we also need to form that query into our base change service. So if we go into what I've done here is I've created a read view async method. So this goes through, it passes in the reference ID, it checks to see if there's a change table attribute, throws an error if there isn't. If not, we set the entity, and then we use this from SQL raw, and that's basically the same SQL that I just showed you. What we can do there is then we can set which reference ID we wish to see data from. You can also do things like the order by as well, and it's always routing to this change view entity as well. So we've got our API running, and what I want to do now is I want to test out the change ignore and change reference attributes that we've done. So in our SQL Server database, in the games database, we've got the engine table, which I've run the migrations for. We've created 2 new records, an Unreal Engine 4 and an Unreal Engine 3. Let's now go ahead and use Postman to create a new video game. Most importantly, we're going to set an engine ID of 2. So let's go ahead and do that. As you can see, it's returned a 200 response with an ID of 8. Let's go ahead and update that now. We're going to change the title to Friday the 13th. We're going to change the engine ID to 1. Cool, so we've got a 200 response. Let's see how that looks in our video game change table. So it's created 2 new records. The first one is when we created the record, and the second one is when we updated it. Let's examine that a bit further in our JSON prettifier. So as you can see, it's ignoring the ID for the actual video game, but it's including the ID for the engine. Now what we've done with that is we've created a chained reference on that property to ensure that we're capturing it. Most importantly as well is that we're also capturing the engine name of Unreal Engine 3, so that means we can now log data changes for any references that are assigned to an entity. Let's now go ahead and look at the other record for when we updated it. So as you can see here, when we're updating, it's captured our engine ID and more importantly, our engine name. It's also gone ahead and updated the title as well. Now lastly, I just want to test out the read view async where we can basically convert the JSON into a SQL Server query and render it out through our API. So let's go ahead and see if that works. As you can see, it's worked there. It's got our created record and then it's got our update records there as well. So lastly, I want to go ahead and talk about test-driven development. Now, if you work in a large technology company, it's probably second nature to you. However, if you work in a smaller company, then time might be of the essence and it might get pushed back. But I want to show you the importance of testing in this instance, particularly in a complicated application like this. Now, what I've done with this is I've created a host. That's basically the same way that it creates an ASP.NET Core application. We can also go ahead and build our scope for dependency injection. And what I've done for this test is I've created a couple of test services and DB contexts. With the test video game service, it's inheriting the base change service. Now, if you remember, we had generic types for the DB context, and this is where it comes in. We're basically passing in our test DB context along with passing in our test entity. We can then go ahead and run our tests. So let's run them now and see how they perform. So yeah, as you can see, they've all passed. We had 10 tests and they're all passing. Let's go ahead and make a change though in the base change service to see what happens. So let's get rid of this save changes async in the create async method. So we've gone ahead and done that. We've got rid of that change and let's rerun the test and see what happens. Oh no, you can see an issue here. That one change has basically said that only 30% of our tests are now passing, only 3 out of the 10. It's that one little change that has made this not to work. So this is the importance of test-driven development, where basically one line of code is the difference between all 10 tests passing and only 3 of them passing. Let's go ahead and put that back in. And we should see that they all pass now. So there you go. That's the difference.
So there we go. We've got a working example of logging data changes in Entity Framework. If you wish to use the code or the database, you can do. There's a link on the screen for you now. And if you've got any questions about what I've been talking about, you can go to roundthecode.com, click on the contact form and drop me a message. Now for more articles, more .NET articles, visit roundthecode.com. Subscribe to my YouTube channel at roundthecode.com/YouTube and follow me on Twitter. It's @roundthecode. And I will see you next time.